Welcome back to our Math 171 video series. In this set of videos, we'll go over how to write polynomial functions in factored form and drawing graphs of them using the factored form. Here, we're given a picture that has a whole bunch of curves and squiggles in it, and this is called a polynomial function. We can use this graph to find all of the zeros and multiplicities and eventually write our polynomial function. Let's first begin by examining the zeros. The zeros of a polynomial function are located anywhere where the function touches or crosses the x-axis. On this picture, we can see three positions where the function touches the x-axis. It touches once here at x equals -2. Then the function curves upward and touches the x-axis again at x equals +1, curves upward massively, and then comes back down through x equals 3. Therefore, we can say our zeros are x equals -2, x equals 1, and x equals 3. To find the multiplicity of those zeros, we'll need to look at the shape of the graph as it goes through the axis. You may be able to see on the right at x equals 3 that the line simply crosses straight through directly. If the line crosses directly, that means the multiplicity is 1. This is another way of saying that this zero is first power. If you look to this zero at x equals 1, you can see that the function touches the axis, but then bounces back up. If the function touches a position, we can say that that zero is second power, or multiplicity 2. Far on the left, where the x is equal to -2, you can see that we cross through at -2, but we don't cross through directly. We do a strange little squiggle as we cross through. If you see the squiggle at that position, that means you have a multiplicity 3 zero, which is another way of saying that this zero will be third power. To write our polynomial function based on this graph, we'll begin by taking each of the zeros and moving them from the right to the left. When we do that, this -2 will become +2 because we'll add 2 to both sides. We'll get x plus 2 is equal to 0. This is why we call the x plus 2 a 0, because when we move the -2 over and get x plus 2, we now have 0 on the right. After we move each zero to the left, we will raise it to its own power based on the shape that the graph makes when it crosses through the axis. Because at x equals -2 gave us a squiggle, that means that zero will be third power, and this will give us x plus 2 raised to the third power. If we do the same thing at x equals 1, we'll subtract 1 from both sides, and this will give us x minus 1 equals 0. At x equals 1, it touched but bounced off, and that means we'll have second power at that position, giving us x minus 1 squared. At x equals 3, it crossed straight through, meaning that at x equals 3, we have first power. Once again, we take the 3 and move it to the left by subtracting 3 from both sides. This will give us x minus 3 is equal to 0, and since it's first power, we don't have to write the extra power onto it. We can assume it is first power. Now, to write the polynomial function, we will write a multiplication chain of all three of those factors we've just written. So we will now say y equals x plus 2 to the third power times x minus 1 squared times x minus 3 with no power on it because it's first power. In one final addition, we must include a leading coefficient that we'll multiply everything by, and we'll call that a. That a is our leading coefficient. Just like how a quadratic function has leading coefficient, a polynomial function must also have one. We don't know what it is yet, but we'll find that on the next slide. However, just based on this, most of our work is finished already. The only thing left to do to write the polynomial function is to figure out the value of a. In order to find the value of a, you can use any point other than the zeros we marked previously, which are -2, 1, and 3. Any points other than those will work, but the easiest point to use is usually the y-intercept. The y-intercept at this position will be 0, 2, the place where x is 0, but y is 2. The reason why is because it's easy to plug 0 into this function and then figure out our a, because we know both x and y. We will replace the y with the number 2 and replace all of the x's with the number 0. Any known point would work other than the zeros I've marked, but this will take the least amount of math. So we'll rewrite the function plugging in 2 for y and 0 for x. Now we handle the arithmetic. We'll have 2 is equal to a multiplied by 0 plus 2 raised to the third power, which is 8. Then -1 to the second power, which is +1, multiplied by -3. If we multiply 8 times 1 times -3, we will get -24 times the letter a. Now, to get a by itself, we will divide both sides by -24. If we take 2 over -24, this will reduce to -1/12. You can leave the a as a fraction. This will be our new leading coefficient for this polynomial. To write our final answer, we will now write that -1/12 in place of a and just rewrite our polynomial. Our y will equal -1/12 times x plus 2 to the third power times x minus 1 squared times x minus 3. This is how we come up with a function that goes with any given graph. We find the zeros, we check their multiplicity, and then we find a point on the graph that's not too much work to evaluate. Once we use that to find a, we have completed writing the polynomial.